no one's used this exit. Here you can see the number of people who've used the normal exit in the situation where they followed the VCA, and this is the case where the VCA is not enabled. You can see it's pulling in all these people from different areas if you don't have the VCA enabled. So to conclude then, the VCA capability within Exodus allows engineers to determine the coverage of a signage system, which is quite important in its own right. Put a sign somewhere, where can I see it from? It's essential in large and complex buildings such as airport terminals, hospitals, shopping malls and so on to be able to determine the extent of your signage system. The engineer can contemplate an impact, the impact of current or proposed signage systems. So you can do an experiment, change the signage system and see what impact that might have. And it allows Exodus to produce greater realism when simulating circulation and evacuation cases. Just some of the further work we're doing. This is an experiment we're doing with people looking at signage systems, and we're changing the angle of the sign. One of the things that the regulations don't tell us in terms of the termination distance is, how far away can I see a sign if I'm looking at a sign on an angle? How far away can I be before I see that? It's not the same distance if you're looking straight on. And this is some of the data we've been collecting showing how the termination distance decreases as the angle that you make to the sign decreases. So we're using this information to regulate our termination distance of the signage in the software. I'm going to finish up here. I'd just like to remind people that we've got a live demo on Tuesday at 14:40 in this room, and the Exodus software is available in room 215 to play with if you'd like. Thank you.
Thank you. Right, any questions? Right, question? Okay, I'll pass the mic.
Erica Kulagowski, NIST. I wonder if you could talk more about the data collection techniques when you were talking about putting video recorders on people's heads, as far as the instructions that you gave them.
Yeah. We're at the moment, we're still designing those procedures. But basically, they'll have a helmet, a microscopic video camera attached to it, and the camera will see what they see. And we're putting them in situations, for example, in a museum, and we're saying, you've got to get out of here by the shortest route possible and the shortest amount of time. You can use whatever means you want. It's all open to you. And if you get out within a certain amount of time, we'll give you £5. So now you get out of here as quickly as you can, and the video will record what they're going through, what they're doing. We'll see the signs that they've ignored or used. We'll then analyze the video with a questionnaire as well, which will then interrogate the subject, and then that's basically how we're doing that. We've not. No, we've been doing the experiments looking at the termination distance depending on angle.
Okay. Any more questions? Okay.
Alan Penn, UCL. It always occurs to me that architecture has failed when you need signs. And I just wonder if you've been thinking about your Sainsbury's case of rearranging their gondola layout so that people can actually see the exits from more locations.
Yeah. I mean, that would be the obvious thing to do, but it's to get people to put even 4 signs up is an impossible task. To get them to rearrange their gondolas, I suggest you'd have to, well, I don't know what you'd have to do to get them to do that. Maybe one of our friendly, well, actually, no, I won't say that. I don't know what you'd have to do to get them to do that.
Hi Ed, Glenn Horton from Lock Kerry Consulting. I'm interested in your treatment of the signs. In your opening remarks, you were talking about visual clutter, and obviously the ability to physically see a sign doesn't mean to say that that you'll respond to it or recognise it. Have you done anything to give the sign some kind of characteristic or constant which would impact on that at all?
No. What the model does is it'll take the clutter into account. And so the clutter, other signage, will create shadows, and you won't be able to see it from certain areas. So all we're doing at the moment is calculating where is it physically possible to see the sign from, including the clutter, taking that into account. The experimental work we're going to be doing with the video recording and so on, that's designed to determine the probability of take-up, actually detecting the sign and reacting to it.
I'm sorry, I don't have any more time for any more questions. So if we would like to thank Professor Galea.